Okay, this video is on polynomial adding and subtracting. And if you've been following all the introductory videos to polynomials, which has probably been more than I initially planned on, but you've probably already figured out that adding and subtracting polynomials is really just a matter of combining the like terms. And if you came to that conclusion, you'd be absolutely right. I've got an addition problem here, got a subtraction problem here. The parentheses are just to denote which polynomial is which, and in the case of addition, they're completely unnecessary. We're adding all these terms, or we're combining the like terms, and we don't really need this separation. With the subtraction problem, we do need the separation, especially on this second term, because this negative sign is essentially going to distribute across this second polynomial, okay, the one we're subtracting away. So we want to make sure that we do distinguish, and this parentheses actually makes a difference. If we just take those parentheses away and leave that negative there without distributing and changing the sign of all these terms, we'll be making a big mistake. So there is that additional twist with subtraction. Other than that, it's combining like terms. So let's get started. First of all, this particular one is written in standard form, but this one's not. If this one was written in standard form, then we should be able to kind of match things up right across. Unfortunately, that's not the way this one was written, so we're going to go ahead and combine like terms by first identifying the terms that have the exact same variable component. So I've got a 3x squared and a negative 7x squared. I can combine those together, get a negative 4x squared. Next, and I want to go descending order of degree, because then my answer will already be in standard form and I don't have to rewrite it, and I like saving time. So here we have a negative 4x, here we have a positive 2x. Those are going to combine to make a negative 2x, and now we've taken care of those terms. All that's left is the negative 5 and the positive 8. When we put those together, essentially 8 minus 5, we get 3. So when we're done combining these two polynomials, or adding, if you like to call it that, we end up with a quadratic trinomial with a leading coefficient of negative 4. Okay, so those are the identifying the important things. You can also say that it has a constant term of 3 if you wanted to. So those are the identifying features of that polynomial. Say a lot about it, and as you learn more and more about these types of polynomials, you'll realize just how much those things come into play. Let's go ahead and subtract now. Here it's a little different. And what I like to do with subtraction, and you don't have to do it this way if you can keep it straight in your head what you're doing, but I like to go ahead and remove the parentheses first, and when I do, I want to distribute this negative sign, essentially like multiplying by negative 1, across each of these three terms. That way, I no longer have to think of it as a subtraction problem. I can just think of it as combining like terms. So let's do that. I'm going to write 6y Nothing changes in this part of the subtraction problem. Nothing changes in the minuend. We're only going to change the subtrahend. We're going to distribute this negative now. So this 9y to the fourth becomes a negative 9y to the fourth. This negative 7y becomes a positive 7y. And this positive 2y squared becomes a negative 2y squared. Once we've done that, once we've distributed that negative across the subtrahend, then all we have to do is look for like terms and put those together. And this is not written in standard form, neither is this one. So what I want to do is kind of scan across for the highest degree. And I got a couple of terms that have a fourth degree. Those are definitely my highest degree. So I have an 8y to the fourth, and I'm going to subtract 9y to the fourth, essentially a negative 1. I'm just going to write it as negative y to the fourth degree. Remember, there's an invisible 1 there. Scan again. I don't see anything raised to the third power, so I'm going to go to the second power. I've got a variable with the second power there and a variable with the second power there. 6y squared minus 2y squared leaves me with 4y squared. All well and good. Linear terms. I got a linear term here, negative 5y, and a linear term here. Positive 7y leaves me with a positive 2y. And that takes care of everything. I don't have any constant terms in these particular polynomials, so nothing there. So what I have here, I have a quartic trinomial with a leading coefficient of negative 1 and no constant term. Unless, of course, you want to think that the constant term is a 0. We could add a 0 on the end. Wouldn't change the polynomial at all. And it might help us realize in the future what that constant term means. And we'll talk to that in a future video. But that is all there is to adding and subtracting polynomials. I want to add one thing that these examples didn't show. And that is, if one of these had a particular variable part that didn't have a counterpart on the other side, you'd simply just include that in the result. You wouldn't have to combine it with anything. You could just kind of follow into the result. So watch out for that, and I think you can do adding and subtracting just fine.